Okay, sir. Namaste. So in this class, what we are going to discuss about the boilers. What are called as boilers? The definition of boiler. So boilers are the closed metallic vessel. What are boilers? Boilers are closed metallic vessel. What is the purpose of boiler? To generate the steam by the application of what? Heat. So we are going to generate the steam at the required pressure of required quality by the application of heat. So this is the definition of boiler. Is it clear? So what is boilers? Boilers is a closed metallic vessel which generates steam at the required pressure and temperature by the application of heat. So this we are going to call as what? Boilers. Now let us come to the various classifications of boilers. Okay. So what are the various classifications are there? The first classification based on circulation of water and hot gases. So this is the first classification. Okay. So first classification is based on circulation of water and hot gases. I will explain it. Okay. The second classification, that is based on location of furnace. So that's the second classification. The third classification is based on circulation of water. So there is a difference between the classification A and classification C. So the classification is based on both circulation of water as well as circulation of hot gases. So next D, based on position of shell. Next, the last is based on application. Is it clear? So these are the major 5 classifications of boilers. What is the first classification? Based on circulation of water and hot gases. Okay. Next, second one, based on location of gases. Third one, based on circulation of water. Next, based on position of shell. Next, last one is based on the application. So these are the various classifications. Now let us come one by one. So what is the based on circulation of water and hot gases? See, suppose these are the tubes. What is this? Tubes. Okay. So here also have tubes. So if inside this tube, if I am going to supply the hot gases, inside the tube, okay, what is the meaning of hot gases? Steam. No. So when I am going to burn the fuel, that is fossil fuel, if I am going to burn the fuel, that is coal, what happens? We are going to get the hot gases, the heated gases, that we are going to call as hot gases. If I supply this hot gas inside the tube, these tubes are surrounded by water. So this is what we are going to call as fire tube boilers. Are you able to understand? If the hot gases are supplied inside the tubes are surrounded by water. So that kind of boilers are called as what? Fire tube boilers. Okay. So now what water tube boilers. Here you got water tube boilers in red. Can you just give it a try? See, the water is circulated inside the tube, which is surrounded by what? Hot gas. So that we are going to call as what? Water tube boilers. So based on the first classification, that is based on circulation of water and hot gas. So we have two classifications. Under that we have two types. Which are those? Fire tube boilers and water tube boilers. What are fire tube boilers? If the hot gases is supplied inside the tube surrounded by water, so then that kind of boilers we are going to call as what? Fire tube boilers. If hot gases are supplied, water is circulated or supplied inside the tubes surrounded by hot gases, so then it is called as what? Water tube boilers. Is it clear? So this is a major classifications on the based on circulation of hot gases. Is it clear? Next classification. What is the next classification? Based on location of the hot gas. If the combustion of fuel take place outside the boiler, okay, the combustion of fuel takes place outside the boiler, then it is called as externally fired boilers. It is called as what? Externally fired boilers. If the combustion of fuel takes place inside the boiler drum, so then it is called as internally fired boilers. Light on. Okay. If the combustion of fuel takes place outside the boiler drum, then it is called as what? Externally fired. The combustion of fuel takes place outside the boiler drum, then it is called as externally fired boilers. If the combustion of fuel takes place inside the boiler drum, so then it is called as internally fired boilers. Is it clear? So based on the location of furnace, we have internally fired, externally and externally fired. Is it clear? Now, the next classification is based on circulation of water. How the water is going to circulate. For example, have you observed the boiling water? What happens? So the hot water comes up, cold water will goes down. So this is called as natural convection. So when you observe the boiling water, so it will boil now. What happens? The hot water comes up, cold water goes down. So there will be a circulation. So this we are going to call as natural convection. If I am going to supply the water to the boiler, if it is a natural convection, if the circulation of water is taking place naturally, so then it is called as natural convection boilers. If I am going to pressurize the water with the help of pumps, if I am going to circulate the water inside the boilers with the help of a pump, so that we are going to call as forced convection boilers. Okay, natural convection boilers, where the movement of water takes place by the naturally due to the temperature difference. Due to the temperature difference, the water is going to circulate. So that we are going to call as what? Natural circulation boiler. The second type is there. So we are going to force the water for the circulation. So that we are going to call as forced circulation boiler. Is it clear? So the third classification is based on circulation of water. We have natural circulation boilers and forced circulation boilers. Is it clear? So next, the fourth point, based on the position of the shell. So shell means what? The as I already told. So boiler drum, right? So the closed metallic vessel. If the boiler is mounted horizontally, then it is called as horizontal boilers. If the boiler drum is mounted vertically, so it is called as vertical boilers. Is it clear? So that's why it is called as based on position of shell. Okay. So next one, the last one is application. Depending upon the application, whether it is a locomotive. What is the meaning of locomotive? Moving. So earlier days, so the trains were running with the help of steam boilers. So that is a locomotive type of boiler. And another there will be a stationary. So for example, in the power generation, the boilers are not moving; it will be stationary. Hence, it is called as stationary type of boiler. So that's why it is based on the application. What is the first application? Locomotive application. The second one is the stationary application. So this is the brief classification of boilers. I hope you understood. Please take it. So now I am going to explain you the Babcock and Wilcox formula. So first we should know how to write it at as easiest method as possible with the very least time. So that is what the objectives of the engineers, right? We have to use the less resource and a less time. So we should get an optimum solution. So I would like to explain how to write this simple one. So first you have to write the boiler drum. When you go boiler drum. So this boiler drum has to be mounted on something, right? It has to be supported. So it is mounted on a brick structure. What is this? Brick structure. So this is a cross-sectional view of the boiler. What is this? Cross-sectional view of the boiler. So this is a brick structure. Okay. So we are going to fill the water. ಎಷ್ಟು fill ಮಾಡಿರ್ತಾರೆ? Not full. It will be filled half. Half of the boiler drum is filled with water. So now water has to circulate, right? So how the water circulation is going to take place? It will be having downtake header. What is this? Downtake header. So this one is downtake header. Okay. So next we have uptake header. So what is this? Uptake header. Okay, so this is a downtake header and this is a uptake header. So in between this downtake header and uptake header, we will be having number of water tubes. So these are the water tubes. Clear? So now I need to generate the hot gases, right? So I need to generate the hot gases. So I need to mount the furnace. So this is the furnace where the combustion of fuel is going to take place. So this is the coal I am going to take. So here happens combustion take place, and after combustion what you are going to get? Ash. You are going to generate hot gas, and the outcome is the ash. So what is the fuel I am going to use? Coal. What is this? This is the furnace grate. This is the furnace. Okay. So what is this? This is the boiler drum. So now I need to class the hot gases. Okay, I need to class the hot gases. I need to give the directions to the hot gases. So that I am going to give with the help of baffle plates. What is this? Baffle plates. What is the use of this baffle plates? So whatever the hot gases are is generated, in hot gases generated. So if I am not going to give a proper direction, it will go randomly. Yes or no? So that's why. So these are the baffle plates. Baffle plates, which is going to give the directions to the hot gases. So ನೋಡಿ ಹಿಂಗೆ ಹೋಗುತ್ತೆ, ಈ ತರ ಬರುತ್ತೆ. Then it will go like this. Then it will go like this. Then after it goes to ಎಲ್ಲಿ ಹೋಗುತ್ತೆ? Chimney. It goes to chimney. So this is the chimney. Is it clear? ಅರ್ಥ ಆಗ್ತಿದೆಯಾ? Okay. So now it is going to generate the steam. The steam will be stored in the steam space. So this is the region where the steam will be. So what we want in the temperature enthalpy diagram, we learn the different types of steam. Yes, no? So dry steam, wet steam, dry steam. So for the application purpose, the superheated steam is preferable. Okay, it is always preferable for a superheated steam. So now whatever the heat or whatever the steam is produced is only a wet steam, because the water will be flowing from here and will get heated up and the steam will be stored over here. So ilinga barutala, so steam will be hotter, right? So it will be stored above the water. So now this is a wet steam. So this wet steam I need to convert into superheated steam. How to convert it? So for that we have T tube. Enanta ready? T tube. What is this? T tube. And this T tube is connected with U tube. Okay. So we have a T tube that is connected to U tube. So the wet steam, so it will goes to U tube through T tube. Okay. So where once again the heat will be extracted from the hot gases and it is going to produce the superheated steam. So this is cross sectional view, right? So that's why we can't able to show all the parts. So this is a U tube. So from the U tube it will go to the steam stopper. It will go to the steam stopper. So where we are going to control the flow of steam. Here steam generated out superheated steam. So we are going to control it, and that will be the steam that is generated, that will be used for different applications. Maybe for the power generation or maybe in other food processing industry. Is it clear? And to operate this boiler safely, we need some mountings and accessories. We need some mountings and accessories. What are the different mountings we have? See, we have feed valve. What is this? Feed pump button. Here, feed valve. So where the water will be fed to the boiler drum. Okay, water has to be fed inside the boiler drum. Through which one? Feed pump or feed pump. Next, to control the level of water, we have a, what is this? going to show you the level of water inside the boiler. So this is water level indicator. And there is another one is there, pressure gauge. What is this? Pressure gauge. What is the use of pressure gauge? So as I told, we need to generate the steam at the required pressure. So therefore I need to check what is the pressure of the boiler, right? So that's why this is a pressure gauge. So not only pressure gauge, have you seen the cookers? We have a safety valve. So the visual model. So that is a safety valve. So sometimes if the pressure of the steam, boiler is going to increase, what happens? It is going to explode. It will be just like a bomb. So that's why we should have a safety valve. So that's why we have a safety valve. So just like a weight on the pressure safety valve. It is going to release the excess pressure. Safety valve. So in cooker, have you observed there is one small hole with there? One small hole is there. So if this safety valve is not going to work, it is going to diffuse one chemical one metallic element with it. So if the temperature of the cooker reaches certain limit, it is going to melt and it will be open. So the pressure is going to come. So that we are going to call as fusible plug. In the down only mount model. What is this? Fusible plug. Okay. If the safety valve is not going to work, so this it is going to melt and it is going to reduce the pressure of the boiler. Okay. Are you able to understand? Okay. What is this steam? Top water. See, after many days of working, it has to be cleaned. So these boilers are so huge. So we are going to provide a manhole. What is the meaning of manhole? A human being can go inside the boiler drum for the cleaning purpose. So that's why it is called as what? Manhole. So if there is a water, so there will be a sand particles will be there. Yes or no? So here the water will be circulating. Water will be circulating, right? So that's why we are going to produce a mud box. What is this? Mud box. What is the purpose of mud box? The waste sand particles which will be settled inside the mud box. So it will be cleaned regularly. So therefore the flow of water takes place without any obstructions. Is it clear? So this is the way you have to write the stage. Very easy, no? So if you know the explanation of it, you can just write it by explaining. Yes or no? So now explanation part. What is the explanation? How you will explain this? So this is the structure. Yes or no? Big structure. Now the explanation part. The first point that what you have to write is classification. What kind of boiler is this? So what is the first classification? No, classification. I told you the different classifications. Hot gases and water. So what kind of boiler is this? This is a water tube boiler. Right? Because why? Because water is flowing inside the water tube. And it is surrounded by hot gases, not steam. Hot gases. Okay, so that's why this is a water tube boiler. What is the second classification? Based on location. See, this is a boiler drum. Okay, where the furnace is placed, whether it is inside or outside. Outside. So that's why this is an externally fired boiler. What is the third classification? Based on downtaker. From downtaker, the water will flow through the uptaker. So due to the temperature difference, so here the water can heat up, right? The hot water will goes up. So the circulation of water is taking place naturally. So this is a naturally circulating type of water. What is the fourth point? Based on position of shell. So what kind of boiler is this? Horizontal one. Okay, last one is the stationary type. So this is the stationary type of. Is it clear? Classification of that. So now you have to tell this in only one sentence. What kind of boiler is this? So this is a Babcock Wilcox boiler, which is water tube boiler. Next one. Stationary boiler. Next one. Circulating. If you write this statement, you're going to get 2 marks. Are you able to understand?
Yes, sir.
So next one is construction. First point is over. You have to explain the classification. So next one is construction. So we have to explain the construction. How to explain? So what is the first part we have? We have a boiler drum. So it is a metallic vessel which is mounted on a brick structure. Okay. So first you have to explain the boiler drum. So what is the next major part? Brick structure. No. So boiler drum is over. So next one is downtaker and uptaker, or you can say the water tubes. Water tubes. Okay. So this Babcock and Wilcox boiler consists of a downtaker and uptaker, and many other water tubes are placed horizontally, and it is mounted as shown in the sketch. So that is the water tubes. So what is the next thing? The major thing, we have a baffle plates. What is the baffle plates? So the hot gases which is generated inside the furnace. So the baffle plates are going to give the directions to the hot gas. It helps in the circulation of hot gases around the water tubes. Okay, so that is what we have to explain the baffle plates. Another major thing that we have to explain is the superheater. Superheater. So the steam, the wet steam which is stored in the boiler drum, it will be converted into a superheated steam with the help of U-tube. U-tube. It is not YOU. Okay? It is a U-tube. U-tube. And what is this? T-tube. So superheater. How are you going to explain the superheater? It is a U-shaped tube. So the wet steam from the T-tube comes to the U-tube, where it extracts. Where the wet steam will be converted into superheated steam with the help of hot gases flowing around it, and finally it is circulated to the further application with the help of steam stove. So these are the major constructions. You have to explain the boiler drum, water tubes, next one is baffle plates, and next one is superheater. Now it is the working. Third point is, so here we have to explain circulation of water. How the circulation of water is taking place inside the boiler. Next you have to explain the circulation of hot gases. How the hot gases is circulating. The last point is you have to explain how to generate the superheated steam. Only 3 points, 3 paragraphs. Okay. So how to explain that? See, the water is fed to the boiler drum with the help of feed pump. So the level of the water is rated up to half boil. Okay. So the water from the boiler drum flows to the downtake header, then to the uptake header, then it goes back to the boiler. So that is the circulation of water. Now the next point is circulation of hot gases. So due to the combustion of coal or fossil fuel, the hot gases are generated. These hot gases will be circulated around the water molecules with the help of which one? Babcock Wilcox. And finally, it will pass into the atmosphere through steam. Okay, that is the circulation of hot gases. So during this process, during the circulation of hot water, during the circulation of hot gases, the water extracts the heat and it will be converted into steam. And steam that is generated will be stored in the steam space of the boiler. So this is steam space where the steam will be. Is it clear? So next, what is the next thing? How we are going to convert the wet steam to the superheated steam? The steam which is there in the steam region, okay, it will be passed to the U through heat tube, where it is going to extract the heat from the hot gases and it will be converted into superheated steam. And this superheated steam is used for further application through steam pump. That's it. Is it clear? Have you understood?